So what we're going to be working on today is just the vertical part of projectile motion. So free fall and vertical motion. These equations we're going to use starting tomorrow in combination with our x components. Our Vx is equal to displacement over time. All right, so those equations will kind of work hand in hand, in which case you'll need time from one of those two. All right, so from one of the equations that we're going to look at today, you're going to need time. And then with that time, you can then figure out your missing piece or missing equation that you're going to need to go to solve for the final answer. But today's stuff, what we're going to do is we're going to walk through some of these example problems. Okay, so V sub y is your vertical velocity. Vi is your initial velocity. If an object is dropped, is launched, is rolled, the initial velocity is going to be 0. G in these equations, all right, we are going to use -10. The actual value is -9.8 or -9.81 meters per second squared, depending upon what source you're looking at. But for the easiness of the calculations, we're going to use the -10, and then t is time. So note, guys, that this value is never given specifically in one of these problems. So you must just know that, okay, it's g is -10. So what I wrote out for the first one, what is going to be the velocity of a ball that at 6 seconds if this thing was thrown straight up at an initial velocity of 42 meters per second? So they told me right off the rip, the initial velocity is 42, and they gave me a time. They didn't tell me anything else. And I wrote out the other variables. So I typed in that g is -10, and we're looking for Vy. So the first 3 problems, we're going to use this equation. So then underneath, what was our Vi? It was 42. And then we're doing -10 times 6. Okay, so that leaves us with 42 plus a -60. And that is going to give us a final answer of... Now, to get a subscript on a Google Doc, all right, you hit Control, comma, and then Control, comma again to get out of it, if you didn't know that. All right, so like the exponent is Control period. This one is Control, comma to get the subscript. So 42 plus a -16 should give me or 42 plus a -60 should give you a -18, and the unit for velocity is going to be meters per second. I'm just going to highlight that answer. All right, the second one. When an apple falls out of a tree and it takes this 1.75 seconds to strike the ground, how fast was it going? So they want to know how fast it's going as it hits the ground. Well, again, this is the only equation we have. So this is how you guys should do these problems. All right, what was our initial velocity? They don't give me in the problem. So if it's dropped, all right, an apple falls out of a tree, if it's dropped, whatever, slash, if they don't tell you what the initial velocity is, the initial velocity is going to be 0. Okay, how long was this thing in air for? It was in air for 1.75 seconds. And they want me to solve for Vy. Okay, well, I don't know. What is gravity? -10 meters per second squared. Okay, that's always going to be that number for our purposes here. Okay. So then I'm just going to go and I'm going to type everybody in. So Vi was 0. Great. Plus gravity, which was -10 times this, 1.75. So that's going to leave us with a final answer here. V sub y is equal to negative 17.5 meters per second. So what is the negative telling me? That negative is telling me that it's on its way down, if it's on its way downward. So if I think about it, guys, if I threw a pencil straight up in the air, what happens to it? It goes up and then it comes back down. So if gravity is always pulling something downward, if I throw something up, what is its instantaneous velocity at the very, very top of its path? So let's say I threw something up and with 40 miles an hour, all right, and it loses 10 every second. So 40, 30, 20, 10 at the very, very top of its path. That instant in time, it should be 0. But gravity doesn't shut off. So even though the speed at the very, very top is 0, gravity's still acting. So then basically the next second later, now it's picking up 10 meters per second. So now it's negative 10, negative 20, negative 30, negative 40. So the negative meaning is on its way downward. All right, so that, guys, will be done. Number 3 will be done just like number 1 and 2. So then I want to get into the vertical displacement portion. So in this case, d sub y, that is going to be our variable for vertical displacement. Initial velocity vi, again, if it's dropped, initial velocity is 0. If you're not given an initial velocity, it's also 0. Gravity is going to be this constant value here. So what is the displacement of a brick that was thrown upward off the side of a building with an initial velocity of 40 meters per second? So we're given that. We're given this 40 meters per second piece. Gravity is not given, but you guys have to know that in these problems, it's always going to be that value. It's always going to be that negative 10. And it was in air for 6.9 seconds. So, given this equation, we're going to just start to type everybody in underneath what we have. So VI was 40. How long was it in air for? 6.9 seconds. And then we're going to do this 1/2 negative 10 times t squared. So t was this 6.9 all right, seconds. Now this is the important thing to note, that you only square time. So how I do this is, all right, I'm going to do this 40 times 6.9 first, and I'm going to get an answer here of 276. Plus, now how I would do this in my calculator, I would do this 6.9 squared. Then I would multiply that answer by negative 10, and then I would divide it by 2 for that 1/2. That gives me an answer of negative 238.05. So then the last little piece is just kind of adding them together. So d sub y is going to be equal to, add the two values together, and you get 37.95 meters. Now it's positive, so that means it's still, all right, above where it was launched. If you have a dy that comes out negative, that's okay. That just means it's below where it started. So you're going to see that like in number 2, when we do number 2. All right, the apple falls out of the tree. It takes 1.5 seconds to strike the ground. So like right off rip, guys, if you haven't been paying attention, You're only given this one variable, 1.75 seconds. Okay, well, crap. What the hell is the initial velocity? It's not given. I don't have anything. So if you scroll back up, if the object is dropped, or if it falls out of something, or if it's not given, its initial velocity is 0. So, haha. And, okay, well, what's g? G, always this number, the negative 10 meters per second squared. Okay, and then you're going to use the equation. And then just underneath everybody, you start to type in our pieces of information. So 0 times 1.75, doesn't matter. All right, because it's going to come out to be 0 over there. 1/2 negative 10 times 1.75 squared. You're squaring time only. All right, so 0 times anything is 0. So I'm going to do, in my calculator, 1.75 squared. I get 3.065. Times that by negative 10. And then I'm going to divide that by 2. And I get an answer of negative 15.3125. I'll just chop it right there, 2 decimals. Okay, so my final answer, I just add the two values together. So dy is going to equal negative 15.31 meters. Now, this question, I just chopped it off. What is the displacement? If it asks you for the height, can you guys have a negative height? No. So think about it like this, right? If I just kind of do this, make a quick little drawing. Don't mind my awfulness. Okay. Wait, do they have a line? No, they don't have a drawing tool. Oh, yeah, they do. Okay, so here is our tree. Excuse you. Okay, so our tree, we have the little apple that falls downward. So that is why we have a dy here. Oh, God, that's awful. That one was terrible. Back. That's why we have a dy of negative 15.31, whatever. Because it is below, right? So displacement is how far you are from your starting point. Well, if you started up top here and you ended here, you're below where you started. That's why we have the negative. But if it asks you what the height is, well, if this is the ground, right? If that's ground, how high was the apple before? It would just be positive 15.31. Okay. So we don't need that. We're going to delete that piece. But that's going to be like, if a question asks how high up was it, and your answer is negative, if your displacement is already negative, then you can just drop the negative sign. Okay. So in part 3, so you guys have number 3 here to do on your own. You have number 3 on this one to do on your own. So now in part 3, when we have time to fall, notice this is our equation. You have basically two things. D sub y, which is your vertical displacement or your height. So if you want to add that in right here, guys, vertical displacement slash height, you can. And T is time. So trapeze artist misses the trapeze and falls into the net that is 9.2 meters below. How long is it going to take him to fall? Or how much time? How long is it going to... This is the equation that we're going to use. So I'm going to just copy this piece, scoot over here, bam. And then I'm going to go bam. And I'm just going to click in here and I'm going to edit this. So it would be 2 times 9.2 divided by 10 and then square root. So you're going to do what's in first. So 2 times 9.2 equals 18.4. Divide that by 10 and you're going to get 1.84. So if I just do get rid of you, that's going to equal square root of that. 1.356 and change. So if you wanted to round it to 2 decimals, you could. If you didn't, that's fine as well. But that would be how you complete that problem. Okay, same thing for 2 and for 3. You're going to do the same thing. Then the homework. The homework will be all right, this piece here. It's going to ask you guys to try and figure out what equations to use. So if they're asking you for speed, you're looking for this guy. If they're asking you for how high up it was or how far did it fall, you're looking for this guy. And if they ask you how long it took or how much time, you're using this guy. So let's look at the first one. Rock is thrown out of a volcano. When it started to fall, it took 9.5 seconds to hit the ground. How fast was it traveling when it struck the ground? They wanted to know how fast. That's the equation that we're going to use. So what I would do for me, I'm going to go up because we're looking for Vy. I'm just going to copy that and I'm going to paste this down here so I know exactly what variables I'm looking for. All right, number 2. Same thing. Wants to know how fast. You're going to use the same equation. You're going to use the same variables. Number 3, how fast was this thing going? Again, same piece. Hailstone, how fast was it traveling as it dents the roof? Again, same thing. Now, number 5, though, asks, okay, well, when it started to fall, it took 9.5 seconds to hit the ground. How high was the rock when it began to fall? So when they wanted how high up, right, that would be this guy here, your vertical displacement. So vertical displacement slash height. So I'm going to go up like this. And I'm going to put it underneath here. All right, 6, same thing. Wants to know how high up the table was. You're going to solve for dy. How high is the cloud? dy. 8, how high is the cliff? dy. And 9 and 10, they're asking you for how long did it take or how many seconds. So you're looking for the time, which is this equation here. So the only 2 variables you need are these guys here. So I'm going to Control C that, and I'm going to paste it down here. So now you guys should have, all right, a bunch of worked out example problems. You need to finish, in part 1, you need to finish number 3. In part 2, you need to finish number 3. In part 3, you need to finish 2 and 3. And then these guys here, all right? And if you're not sure, there are completely worked out example problems to help guide you. It's going to be the same setup, all right? So hopefully, guys, this kind of helps us being able to solve for our missing pieces of information. All right, so this is just the vertical component of these guys. All right.